Hi friends, welcome to my YouTube channel. So yesterday we have learned about the types of transmission modes, the first classification such as simplex, half duplex, full duplex communication, and today we are going to listen about transmission modes, asynchronous transmission, synchronous transmission, isochronous transmission. So going to the slides. So when we are considering the data transmission from one device to another is the wiring. So the transmission of binary data across a link can be accomplished in either parallel or serial mode. So there are two types of transmission mode, parallel and serial mode of transmission. So in parallel mode, multiple bits are sent with each click toggle. So each bits are sent with each click toggle, clock tick. In serial mode, one bit is sent with each clock tick. So one bit is sent with each clock tick, and in parallel mode multiple bits are sent with each clock tick. So while there is only one way to send parallel data, there are three subclasses of serial transmission such as asynchronous, synchronous, isochronous. So we are going to listen about parallel transmission and serial transmission. So there are three types of classification for serial transmission such as asynchronous transmission, synchronous transmission, isochronous transmission. So first we are going to learn about parallel transmission. So these are the types of modes of transmission: parallel, serial, and types of serial transmission: asynchronous, synchronous, isochronous. So parallel transmission. Parallel transmission. Binary data consists of ones and zeros organized into group of n bits each. Computer produce and consume data in groups of bits much as we conceive and use spoken language in the form of words rather than letters. So we use letters or words to speak to someone else, but computers use zeros and ones instead of that. So by grouping we can send data n bits at a time instead of one. So we can send a group of data at a time. So this is called parallel transmission. The mechanism of parallel transmission is conceptually simple one. Use n wires to send n bits at a time, at one time. So that means n wires are used for each bit. So the way in which the bit has its own wire and all n bits of one group can be transmitted with each clock tick from one device to another. So each clock tick means there is one bit is sending from one device to another. So this diagram shows n equal to 8 bit. 8-bit transmission is shown here. So typically the 8 wires are bundled in a cable with a connector at each end. So there are some sender and receiver, 8 bits sent together at a clock tick, and direction of data from sender to receiver. So 8 wires are there. The advantages of parallel transmission is the speed. All else being equal, parallel transmission can increase the transfer speed by a factor of n over serial transmission. But there is a significant disadvantage is the cost. So parallel transmission requires n communication lines, wires in the example, so just to transmit the data stream. Because of this expensive, parallel transmission is usually limited to short distances. So that's all about the parallel transmission. The next one is serial transmission. So in serial transmission, one bit follows another. So we need only one communication channel rather than n to transmit data between two devices. So there we need only one wire to transmit data. So the advantage of serial over parallel transmission is that with only one communication channel, serial transmission reduces the cost of transmission over parallel by roughly a factor of n. So the cost is reduced here because only one wire is used. Since communication within devices is parallel, conversion devices are required at the interface between the sender and the line. That means parallel to serial converter, and between the line and the receiver, serial to parallel converter. So in here we need the converter because within the devices there is a parallel communication. Parallel data is sent in parallel mode. So we need a conversion devices such as parallel to serial converter and serial to parallel converter. So serial transmission occurs in three ways. So we already said that asynchronous, synchronous, and isochronous. So this is a serial transmission figure. So you can see there is a parallel to serial converter and a serial to parallel converter, and each side sender and receiver. Within the devices, the data is sent in parallel mode, and outside that line, it is sent in serial mode. So first one is the asynchronous transmission. So asynchronous transmission is so named because the timing of the signal is unimportant. Timing is not important in here. Instead, information is received and translated agreed upon patterns. So patterns are very important here, not the timing. So as long as those patterns are followed, the receiving data can retrieve the information without regard to the rhythm in which it is sent. So we can as long as the pattern followed, we can retrieve the information without the rhythm of which is sent. So patterns are based on grouping the bit streams into bytes. Each group usually 8 bits. 8 bits is the byte. 1 byte equal to 8 bits is sent along the link as a unit. The 8 bit is sent as a unit. That is 1 byte is sent into the link. The sending system handles each group independently, relaying it to the link whenever ready without regarding to a timer. Without synchronization, the receiver cannot use the timing to predict when the next group will arrive. To alert the receiver to the arrival of new group, therefore an extra bit is added to the beginning of each byte. So this is usually 0, is called as start bit. So to let the receiver know that the byte is finished, one or more additional bits are appended to the end of the byte. These bits are usually called these bits are usually ones, and these are called stop bits. So by this method, each byte can be increased to the size of at least 10 bits, of which it is 8 bit is information, 2 bits or more signals to the receiver. So in addition, the transmission of each byte may then followed by a gap of varying duration. This gap can be represented either by an ideal channel or by a stream of additional stop bits. So there is a gap between these group of bits. And in asynchronous transmission, when we send one start bit or 0 at the beginning or one or more stop bits once at the end of each byte, there may be a gap between each byte. So the start and stop bits and the gap alert the receiver to the beginning and end of each byte and allows it to synchronize with the data stream. So this mechanism is called asynchronous because at the byte level, the sender and receiver do not have to be synchronized. But within each byte, the receiver must still be synchronized with the incoming bit stream. That is, some synchronization is required, but only for the duration of single byte. So that's all about the asynchronous transmission. And also, the receiving device resynchronizes at the onset of each new byte. When the receiver detects the start bits, it sets a timer and begins counting bits as they come in. After n bits, the receiver look for the stop bits. As soon as it detects and stop bit, it wait until it detects the next start bit. Asynchronous here means asynchronous at the byte level, but the bits are still synchronized. The durations are the same. So figures show the schematic illustration of asynchronous transmission. So there is a byte and there is a start bit and stop bit, start bit and stop bit, and there is a sender and receiver, the gaps between the data units. So in this example, the start bits are as the stop bits are ones, and the gap is represented by an ideal line rather than the additional stop bits. The addition of stop and start bits in the insertion of gaps into bit stream makes asynchronous transmission slower than forms of transmission that can operate without the addition of control information. So when we are adding these start bits and stop bits makes the transmission slower. So maybe we can neglect that situation without using the start bits and stop bits in the insertion of gaps. So but it is cheap and effective. The synchronous transmission is cheap and effective. The two advantages that makes it attractive choice for the situation such as low speed communication. So because of these reasons, the synchronous transmission is used for low speed communication. So for example, in the connection of a keyboard and computer is a natural application of the asynchronous transmission. That's all about the asynchronous transmission. Then next is isochronous transmission. In real-time audio video in which uneven delays between frames are not acceptable, synchronous transmission fails. For example, TV images are broadcast at the rate of 30 images per second. They must be viewed at the same rate. If each image is sent by using one or more frames, there should be no delays between frames. For this type of application, synchronization between characters is not enough. The entire stream of bits must be synchronized. The isochronous transmission guarantees that the data arrive at a fixed rate. That's all about the isochronous transmission. Next one is synchronous transmission. In synchronous transmission, the bit stream is combined into longer frames which may contain multiple bytes. So there is a multiple bytes and longer frames. So each byte, however, is introduced onto the transmission link without a gap between it and the next one. So there is no gap between the each frames. So it is left to the receiver to separate the bit streams into bytes for decoding purposes. In other words, the data are transmitted as an unbroken strings of ones and zeros, and the receiver separates the strings into bytes or characters it needs to reconstruct the information. So in synchronous transmission, we send bits one after another without start or stop bits or gaps. So the transmission is very speed because of there is no start bit and stop bits and gaps. So it is a responsibility of the receiver to group the bits. So if we have drawn the divisions between bytes, so in reality, those divisions do not exist. The sender puts its data onto the lines as long as one long string. So there is a long one string. There is no division between each bytes or in the frame. So if the sender wishes to send data in separate bursts, the gaps between bursts must be filled with a special sequence zeros and ones. Then that means idle. So there is a idle because if the sender want to send the data separate base, and the gaps between the bursts must be filled with a special sequence of zeros and ones. The receiver counts the bits as they arrive and groups them in 8-bit units. Without gap and starts or stop bit, there is no built mechanism to help the receiving device to adjust its bit synchronization midstream. Timing become very important, therefore, because the accuracy of the received information is completely dependent on the ability of the receiving device to keep an accurate count on the bits as they come in. So there must be the timing is very important in this synchronous transmission, that the receiving device must to take an accurate count on the bits as they come in, because they need to group them into 8 bits of units. So the advantage of synchronous transmission is the speed. With no extra bits or gaps to introduce the sending end and remove the receiving end, and by extension with fewer two bits, move more to the link. Synchronous transmission is faster than asynchronous transmission. So for this reason, it is more useful for high-speed applications such as transmission of data from one computer to another. So figure gives a schematic illustration of synchronous transmission. There is a sender and receiver, and there is a frames of data, and there is no division between each bytes or send. The receiver combine or group this into 8 bits as they come in. So the timing is very important in synchronous transmission. So this is all about the transmission modes. We have already seen that the types of transmission modes, such as duplex, simplex, half duplex, full duplex, and there is parallel and serial communication. In serial communication, there are 3 types of transmission modes: that's asynchronous, synchronous, and isochronous. So that's all about the transmission modes, and see you in the next class. Thank you. So don't forget to subscribe my channel.